All right, so now we'll continue with the June 2022 question number 6 in the statistics paper 2. So here they say the continuous random variable x has probability density function. So given by, you can see fx. So they've broken it down into 4 sections, right? So for x values between 0 to 2, you have 0.1x, which is the PDF. For x values between 2 to 4, you have kx times 8 minus x. And for x values between 4 to 6, your PDF is a, and it's 0 for other x values. So where k and a are constant. It is known that probability of x less than 4 equals 31 over 45. So find the exact value of k. So how do you find the exact value of k? So basically what you need to do here is, so they have told you the probability that x is less than 4 is equal to 31 over 45. So this is, I mean, we are working with continuous data, right? So basically, you can see here x value is less than 4 means we start with x value 0 and 4, right? So this involves these two regions. And therefore, it involves these two PDFs, right? So basically, if I want the probability of x less than 4, what do I need to do? Simply, I need to, the probability is the area under the curve. So this is the PDF. So you integrate, right? So you integrate your curve from 0 to 2. The PDF is 0.1x with respect to x. So that gives you the area or the probability between 0 and 2 plus, okay, because they are separate PDFs, you have to do it separately, right? So this guy, kx, 8 kx times 8 minus x, you integrate between 2 to 4, right? So this will give you the total area or the probability that x is less than 4. So probability, this basically gives you the probability that x is less than 4, and that equals to 31 over 45. So it's just a matter of solving this equation. So I get here 0.1 x square over 2, and I need to input the limit 0 to 2. Here I get k. So obviously here, in order to integrate, we need to do a little bit of simplification, right? So I need to expand the bracket. X into 8 is 8x. X into x is x square dx. Okay, so this goes from 2 to 4. I did not integrate this yet. I just expanded the bracket. So here I get 0.1. So this is going to be 2 square over 2 minus, that's a 0. All right, plus here I'm going to integrate it now. So I get 8x square over 2 minus x cube over 3. And the limits are from 2 to 4 equals 31 over 45. So here I get 0.1 times 2 plus k times, so let's substitute values here. 8 divided by 2, that's 4 into 4 square minus 4 cube over 3 minus 4 into 2 square minus 2 cube over 3. All right, so it's just a matter of solving this equation and making k the subject. All right, so let's simplify. All right, so here I have performed the rest of the simplification. So I think that's pretty straightforward, right? So you can get these answers just typing in the calculator, and you can get k value as 1 over 60. All right. Okay, so moving on to the next part, part B. So part B, Roman number 1, find the exact value of A. Okay, so how do we find the exact value of A? So you can see here, I mean, this is where I have A. So I need to get the value of this. So basically, one technique of doing this would be, we know that the total area under the graph must be 1, right? So here I have the area, probability x less than 4 is 31 over 45, right? So if it is 31 over 45, so I think we can easily get the area between 4 to 6, right? So basically, I know, okay, I know that the total area between 0 to 2. So if I integrate, now you can see here, if I just write this down, 0.1x dx between 0 to 2 plus kx 8 minus x from 2 to 4 plus the next part. So now I'm writing the next part A. If I integrate A from 4 to 6, okay, so the total area must be 1, right? Because it's a PDF. If in order for this to be a PDF, the total area must add up to 1. And I know the area of this part, right? This section. So this is the section, this probability x is less than 4, right? Okay, because it comes until 4, the area. So probability x less than 4, we already know the answer for this part, which is 31 over 45. So this section gives me 31 over 45. Plus here I have integration of a from 4 to 6. All right. Okay, so it's a matter of solving this equation. So I get the integration. Basically, a is a constant. We can take it out. So we are going to integrate simply 1, right? 1 minus 31 over 45. So let's simplify a into, here when you integrate 1, you get x, right? So when you integrate 1 with respect to x, you get x. So you have input your limits 4 to 6. 1 minus 31 over 45. All right. So let's simplify. All right, so the rest of the thing is easy. So you can see this is 6 minus 4. Here I get 14 over 45. So just simplifying 14 over 45, 6 minus 4 is 2, goes to the other side as a half. So you end up getting a 7 over 45, right? That's pretty straightforward. So Roman number 2, find the exact value of probability x is greater than or equal 0, less than or equal 5.5. All right. So basically all you need to do here is I think you can see again. So when we go for x less than or equal 5.5, so we start from 0. Okay, so 0 to 2 range is already included here. 2 to 4 is also included. So the next range, we don't go from 4 to 6, but rather we go from 4 to 5.5. So which is possible, right? We are working with continuous random variable. So I can just do the same thing here for B part 2. So if I want to find the probability that x is greater than or equal 0, less than or equal 5.5, what do I need to do? So I can get the probability by integration, right? So the first part I integrate from 0 to 2, find 1x. Plus the second part I integrate between 2 to 4, kx, 8 minus x, right? So I'm just following this. Okay, 0.1x between this region, kx 8 minus x in between 2 to 4. And then I integrate a with respect to x from where to where. Now, I don't I don't use 4 to 6 now, because if I use 4 to 6, the total thing is going to be 1 as it's a PDF. But they want us to get the probability for x value starting from 0 until 5.5. So I will go from 4 to 5.5 because that's what they want us to get. Okay. And once again, the probability of x, so this region is the probability x less than 4, right? When you add these together, it's the region the probability x less than 4, which we know the answer is given to us as 31 over 45. So that region is 31 over 45. Plus over here, so I'm integrating a is a constant. So basically I end up integrating 1 from 4 to 5.5. And I just need to add this answer, right? I just want to get the probability. So 31 over 45 plus, I think a value, we just found it out, right? So a was 7 over 45. So substitute the a value as 7 over 45. And when you integrate 1, you get x. And your limits are from 4 to 5.5. So just a matter of simplifying using the calculator. 7 over 45. So I get here 5.5 minus 4. Let's simplify and get the final answer. All right, so when I simplify, I get the answer 83 over 90, which is pretty straightforward. So I have also given an alternative option here for those of you who prefer another way. So basically, you know the total area here, right? So we know the total area of the whole thing adds up to, the total area of all these three will be 1, right? So what I do is from 1, I'm going to subtract the region that I do not need. So here I need the area from 0 to 5.5. So the only region that's not included here is the part from 5.5 to 6. 5.5 to 6 goes with the PDF A, right? The constant A. So basically I take the PDF A, integrate from 5.5 to 6, right? And just subtract this figure from 1, the total probability, which should give me the exact same answer as the other one. So you can do either way, right? Whichever way is more comfortable, or whichever way that comes to you in the exam, that's fine. As long as you do one of the methods, it should be fine. Okay, so here, over here, it's just a little bit of intuition, right? So you get the area, the part that you do not require, and you subtract it from 1 to get the area that you require. Okay. All right. So moving on to part C, specify fully the cumulative distribution function of X. So it's 6 marks. Okay. So we have to specify the CDF. All right. So let's do that. Okay, so let's specify the CDF. So you know that you need to specify the CDF for all these ranges, right? From 0 to 2, 2 to 4, and 4 to 6. You have to specify the CDF for all of them. All right, so first let's consider the X range between 0 and 2. Okay, so I'm going to integrate, so what's the rule? We integrate 0.1x, right? Okay, so the lower limit is 0. And when you're getting the CDF, always we use the upper limit as x, right? As long as x is any figure between 0 and 2. Okay, so I'm working on the first guy here, okay? I'm working on the first part here. So 0.1x is the PDF, so I'm going to integrate it from the lower limit 0, and the upper limit we normally use it as x, and x can be any figure or any, I mean, it could be anything, any real value between 0 and 2. All right, so normally the norm here is that you should actually, when you are using your limit as x, it's better to change the letter here, right? So that we can see the substitution of x clearly. So when you're using x here, it's better to use another letter, like use any letter that you prefer. So if I use 0.1 instead of x, I'll use t. Okay, t, and you write instead of dx, you write dt. Okay, so the reason we change the letter here instead of going with x is because you integrate this with respect to, and you know you're substituting the limits here, and your limit has a x. So when your function already has x, it's kind of difficult to see when you substitute the x, right? So because you're substituting x here after the integration. So it's better to change the variable so that it's not going to impact the sum in any way. It's just a simple thing to do. Okay. So I take this part, 0.1, and instead of x, I use t, and I integrate with respect to t. Okay. And the limit, the lower limit is 0. Upper limit, we always use as x when you're going for the CDF, and x is going to be any figure or any real value between 0 and 2. Okay. So let's integrate. What do I get? 0.1 t square over 2, right? When you integrate, and then you substitute your limit 0 to x. So now I can clearly replace the t with x, right? So that comes really easily. So 0.1 divided by 2x square minus the other guy is 0, right? So which gives me 0.05x square. That is the CDF. So this is the CDF function for any x value between 0 and 2, right? So if I use any x figure, let's say I use x is 1. So if I use x equals 1 here, I'm going to immediately, this gives me, if I use x equals 1, I will immediately get the probability x is less than 1. If I substitute instead of x 1. Okay, it will immediately give me the complete area behind 1. Okay, that's what the CDF does, right? Okay, so that we don't need to go there. So we just need to specify the function. So I got the function for x between 0 and 2. So now let's get the CDF for x between 2 and 4. So for x values between 2 and 4, so what is the CDF? The PDF is kx8 minus x, as I told you again. Let's change the letter. So kt8 minus t, okay, with respect to t. I'm changing x to t. And the limits, always you go from the lower limit. The upper limit should be always x. The lower limit in the second case is 2. So lower limit is 2. And the upper limit is always x, where x can be any real number between 2 to 4. Okay, x can be anything from 2 to 4. All right. So, and then I think you know, in order for the CDF to be complete, okay, in order for the CDF to be complete, you know, if I want to find f of 3 in this case, okay, if I want to find f3, I need to get the complete area behind 3, right? Now, you need to realize here that when you integrate from 2 to x, so at the end of the day, when you replace the x with, now, say I want to find f3 here, right? So if I replace x with 3, I'll only get the area from 2 to 3. I'll only get the area from 2 to 3. But the CDF requires me to find the area from the very beginning. That's the definition of CDF, right? So if I want to find f of 3, then I need to find the area from 0 to 3, right? From x value 0 until x value 3. But this gives me only from 2 to 3. right? So what do you need to do here? So if you recall the theory, you need to add the total area from 0 to 2 because that part is not included here. This only includes the area from 2 to x, where x can be any figure between 2 and 4. So you have to manually add the total area between 0 and 2. So what's the total area between 0 and 2? Basically, I need to add the total area. X is less than or equal to. I need to add this, right? In order for this to be a complete CDF. All right. So this is the CDF function. So I can easily get this area x less than or equal to 2. How? I can go to this particular formula and replace x with 2. So even though the equal mark is not there over here, you don't have to worry about it because these are continuous functions, right? The place where one graph ends, the other one would start, maybe not necessarily at the same point. Okay, so if you've done questions in the textbook, I think you should know what I'm talking about. So basically, even though the equal mark is not there here for these continuous functions, the area behind 2, you can still find from this particular equation. Okay, so it's going to be the probability x less than or equal to 0.05. So it's going to be 2 square. All right, so when you simplify this, so this gives me the area or the probability that x is between 0 and 2. So we can think of it like this. So this gives me the total probability of x between 0 and 2, and this part gives me the total probability that x is between uh is greater than or equal to less than or equal to simple x. All right, so if I use simple x is 3 here, so I'm going to get the area 0 to 2 plus 2 to 3. So end of the day, the total area is from 0 to 3. Okay, I hope you guys were able to follow me. All right, so let's get the answer. So I think k value was found, right? We found the k value in part A. K was 1 over 60. So let's take the k out. K is a constant, 1 over 60, I take it out. So this is going to be 8t minus t square, right? From 2 to x. This part I don't need to, it's already an area. So 2 square is 4. So I get 1 over 60. Let's integrate. 8t square divided by 2. That gives me 4t square minus t cube over 3. 2 to x. All right. So this gives me 0.2. All right, so let's simplify.
And 7%.
All right, so you can see here I've done the rest of the simplification. So substituting the x values, the boundaries, the limits. All right, so this is just typing in the calculator. And then so obviously if you want, you can multiply 1 over 60 inside with all three and then add them up. Or what I've done here is I've taken 1 over 60 out from, now 1 over 60 is common to all these three terms. I've taken 1 over 60 out from this guy as well. So when you take 1 over 60 out, it multiplies with 60, right? So I think that's some simple math simplifications here. And then I get these two guys together and I get this answer. Okay, so you can get this same answer with different steps of simplification. You can have lesser steps of simplification. That's perfectly fine. All right, so this is the CDF. Okay, so this is the CDF for any x value between 2 to 4. So if I use any x value between 2 to 4, any real number, it will give me the total area starting from where? It will give me the total area starting from 0. Okay, so that's critical. It gives me the total area starting from 0 until whatever the x value I ask it to give me. Okay, because you can see here, I fixed it in that particular way. Okay, so I'm not done with the CDF yet because you can see I have another part to find, right? So I have to get the CDF for x values between 4 to 6. So for x values between 4 to 6. Okay, so how do we do this one? So you integrate again from the lower limit. So lower limit is 4. Always the upper limit is x, where x can be any real number now between 4 and 6. So here you integrate your a with respect to x. And then remember CDF means, so if I use any x value here, so say I use 5. So if I use 5 here, I'm going to get the area from 4 to 5. But CDF means if I want to find f of 5, it means I want the area starting from the beginning. So starting from 0 to 5. So that's what we require at the end of the day, the total area from 0 to 5. So but you can see here, I'm only getting from 4 to whatever so in this, if I say x is 5, I get from 4 to 5. But CDF requires from the very beginning. So I need to get the total area from 0 to 4. All right, I need to get the total area from 0 to 4. So how do I get the total area from 0 to 4? So I think you can see here, I can now use the CDF function for x values from 2 to 4, right? Because I got this CDF. All I have to do here is replace x with 4 and it will immediately give me the total area from 0 to 4. If I replace x here with 4, okay, so if I replace x here, if I can easily get f4 here, right? I just have to replace the x with 4 and it immediately gives me, okay, so it gives me the total area from 0 to 4. All right, so let's simplify this and get this figure here. Okay, so I get this answer here. You can type it in the calculator. So we get it as 31 over 45. So then what we do is, so basically this is the total area under the graph from 0 to 4. So now what I do here is I want the area from the 0 to 4 area. I need to add it here. So that is so which we got here 31 over 45. Okay, so 31 over 45, the F4 value. You need to add it. Okay, so then if I use x as 5 here, so I have the 0 to 4 area plus 4 to 5. So that gives me the F5. I mean, basically x could be any figure, not just 5. Okay, it could be any real number between 4 and 6. Okay, so it's time to integrate. We found what was our A value. We found that A is 7 over 45. So replace A with 7 over 45. 7 over 45 is a constant. So we take it out and we integrate 1, right, from 4 to x. So 7 over 45. So integrating 1 is, again, so in this case, we should not write x here because we already have in the limit x as well. So let's change the letter. Okay, so A is a constant. Don't try to change the constant. So we'll do with respect to t. Okay, dt. Okay. So when you integrate with respect to t, you get t here, limit 4 to x. So I get here 7 over 45 times x minus 4 plus 31 over 45. Okay, so it's just a matter of simplification. Let's simplify. All right, so you can see that when you simplify, you can expand the bracket. So I get end of the day 7x plus 1 over 15. All right, so now let's specify the CDF function. So let's write everything at. So what is our CDF function? So our capital Fx, okay, our capital Fx is going to be, so the first one for x values between 0 and 2. So you have 0.05 x square. Okay, 0.05 x square. So this is for x values between 0 to 2. Okay, and for any x value before that, so for x values lower than 0, the CDF is 0, right? That's how it should be, right? Send for x values between 0 and 2, 0.05 x square. Next, for x values between 2 to 4, we got the CDF as 1 over 60, 4x square minus x cube over 3 minus 4 over 3. So that's for x values between 2 to 4. Okay. All right. And then the final one, which we got right now, that's 7x over 45 plus 1 over 15. So this is for x values between 4 to 6. And the last, so when you're doing the CDF, you should define the CDF values will all be 1 for any x value greater than 6, right? Because you don't have probabilities more than 6. You know, you reach total probability 1. When you replace x with 6 here, the answer, obviously 7 times 6 over 45 plus 1 over 15 must be 1, right? and anything more than that for any other x value, it's not going to go beyond that. All right, so these are some basic theories that you learn in the textbook as well, right? So yeah, so this is how we define the CDF function. Okay.